Are these two different graphs, or are they supposed to like?
Well, can you write R1 in terms of X and Y? What's the X component of R1?
Isn't that the distance it travels along X?
Yep.
Is that what we're looking for there?
Yeah.
So it would be, you do the cosine thing with 30 degrees and your 10 meters?
Yeah. What's the Y component of R1?
The distance it travels up Y,
Yeah.
which would be the opposite angle?
Yeah.
Is it still cosine or would it be tangent for that one?
No, you gotta figure that one out. All right, and then it wants to know how far they travel. It wants to know the X and Y components. Write it like this in terms of the unit vectors.
But
So
this
is the X component, this is Y component.
But this time we actually use numbers and stuff?
Yeah.
Okay.
Okay.
Does the x hat and the y hat, are they supposed to have a value?
Nope, they're unit vectors, so they have a length 1. Not 1 meter, just dimensionless 1.
Well, we were supposed to use 10 for R instead of R, right?
I think
The magnitude of R, yeah, so
Are we
magnitude,
supposed to put the magnitude in the equation when we're writing?
what's that?
Are we supposed to write 10 meters? The
Yeah, you
magnitude
could do
in the
that.
equation?
I just want to, I really want to see a number, how much this goes in the X direction, how much it goes in the Y direction.
Yeah.
Okay.
Is the R1 component that whole thing? Like,
R1 needs to be written in terms of components. This would be this length here, would be R1 of X, the X component of R1. This length here would be the Y component of R1.
Which one?
Or one, yeah,
You did.
This length here is 10 meters.
that's what I was asking. Okay.
That's what the magnitude of our Y means.
Yes, okay, so that's what I was saying we could do find 30 RX1 sub X over 30.
Why? How come there's no hat on the X?
Because I haven't made this into a vector yet. This is just how far over R1 X goes. I put an arrow on it like this.
Oh,
It
okay,
should be R1 X hat.
okay.
Okay?
That's what we need to find. R1 over X. But
So you need the whole vector R1. Written right out of vector like this. Just give it a try. You'll learn from mistakes.
That's the bottom. Same thing for all those others. If you were to add these two things together, it would be this way. Which is actually,
Okay, you want to do this first part together?
yes.
All right, let's do that first part.
I think we're heading in the right direction now. You get both of those, and then you gotta get both of these two, and then you just do the formula. It's X hat and Y hat.
Okay,
One.
so R1 X. So R1, the X component of R1. This is the adjacent side of that 30-degree angle, right? Adjacent to that 30 degrees. So I could write this as the magnitude of R1, cosine of 30 degrees. See where I got that? Okay, that would be 10 meters times cosine of 30 degrees. What's cosine of 30 degrees? Oh, that's square root of 3 over 2.
8.6.
Okay. What's the y component of R1?
10 sine 30.
Be 10 meters. Sine of 30 degrees. Sine of 30 degrees is 1/2. So that'd be 10 meters and 1/2, 5 meters. Okay? So if I want to write out that vector in terms of unit vectors, I'd see that R1 is equal to this amount, it goes this amount in the x direction. So I'd multiply the x unit vector by this amount. So do 10 meters by the square root of 3 over 2 x hat. That's how much it goes in the x direction, multiplied by the unit vector in that direction. Plus, goes this amount in the y direction, so multiply by the unit vector there, and that's your vector. Bring in components. Okay, how about R2? That's easy. It's going to be
Just
10 and x hat.
that's it.
that's it.
It's this?
It's all in the x direction, right? So it has a length 10 in that direction. So R2 would be 10 meters x hat. Okay? Now if I wanted to add these up, what would I do? Add the x's and then add the y's separately. So R1 plus R2 vectors is equal to 10 meters plus 10 meters square root of 3 over 2 x hat plus 5 meters y hat. Okay? So this is 10 meters, this is like 8.66. Or 8 point, is it 8.6? That's
6.
That's 668.
668?
No, 8.6602.
Okay, 8.66, good. 8.66 meters. Good. So if I were to draw that vector, R1 plus R2, it would point 18.66 meters in the x direction.
That's
So it would go very far in the x direction. R1 plus R2. Very far in the x direction. This is 18.66 meters. And it goes 5 meters up in the y direction. Okay. So if I want to figure out this angle here, what would you do?
It just tangent.
Yeah, so tangent of that angle is going to be 5 meters over 18.66 meters. And so that angle will be the inverse tangent, or arctangent, of 5 over 18.66. Okay.
What makes it the inverse? Instead of just regular tangent?
Well, if we want theta, we know what tangent of theta is, right? Tangent of theta is the opposite side over the adjacent side of the triangle.
Okay.
This is a triangle,
Yeah.
right?
Yeah.
We know this length and we know this side. So we can automatically get what tangent of theta is. Well, tangent theta doesn't tell me what theta is. But if I take the inverse tangent of both sides, the inverse tangent of tangent gives me theta. And then I have to have the inverse tangent of the other side taken as well.
Okay.
Does that make sense?
Sort of. It's closer.
All right. Well, if you guys have any quick questions on the homework, I'll let you guys go. Yeah.